So dear students, welcome to my YouTube channel PCM Academy and myself Prasanth Maulik, MSc in Physics. So we are discussing about linear differential equation. In the last class, we have completed the first part of the second order differential equation. Okay. And now in this class, we will discuss about the second part. In the first part, we have discussed about the complementary function. Now we will discuss about the particular integral, obviously. But if you want to get the handwritten notes, then you can join my Telegram channel. The link is given in the description also. And to continue this course, please subscribe my channel and hit the bell icon also. Okay. So now let me start with the particular integral. Okay. So we have the differential equation, second order linear differential equation in the form of like this, that d2y dx2 plus p into dy by dx plus qy is equal to r. So in the last class, we have put r is equal to 0 and we have got a differential equation called homogeneous equation, and from that we have already found out the complementary function. But to solve the differential equation for the complete solution, we need one thing also, that is a particular integral. Now there are several cases that how you can find out the particular integral, that is various rules according to the various case, that is according to the function of r. So according to the function of r, according to the r, which is obviously the function of x, we will get different cases for particular integral and we will discuss about that thing. Okay, so we will get various r as a function of x, and for a particular form of r, we have a particular rules for finding the particular integral. Before that, let me find out from here the auxiliary equation, or you can say the equation in symbolic form. So let me first find out the equation in symbolic form from this differential equation. So what is the symbolic form? For symbolic form, we have used already that d dx is capital D and d2 dx2 as d square. So now if we use here, so it will be nothing but d square y plus p dy plus qy is equal to r, that is d square plus pd plus q into y is equal to r. So this is nothing but f of d. So f of d into y is equal to r. So what we will get from here, y is equal to 1 upon f of d into r, and this is your particular integral. So what is your particular integral? So particular integral is 1 upon f of d into r. Now let me tell you what are the rules of finding the particular integral according to the form of the function r. Okay, so there are various cases. So let me tell you one by one. Okay. So the first case that we are going to discuss about, when case 1. Okay. What is your case 1? When r is equal to e to the power ax. If your r is equal to e to the power x. So in that case, particular integral will be in this form, that is nothing but 1 upon f of d into e to the power x. Now how you can find out this particular integral from here? You would just put this d as a. So you have to put d as a. So this will be function of a. So that will be f of a e to the power x, and obviously it will provide, it should provide actually f of a not equal to 0. Okay, but if f of a is equal to 0, then you have to move one step further, that is you have to take the differentiation of this f of a. Okay, in that case, if your f of a is equal to 0, if f of a is equal to 0, in that case what you have to do, your particular integral will be in that case 1 upon, you have to take the differentiation of this f of d and then you have to put a. So that will be your f dash a, and one x will be here, so it will be x e to the power x, it will be in this form. Okay, so your particular integral will be in this form, and obviously here provide f dash a not equal to 0. But again, if your f dash a is equal to 0, then what you have to do in that case, you have to take the second derivative of this and put f for d. So in that case, your particular integral will be, if f dash a is also 0, then your pi will be, instead of x, now it will be x square e to the power x, and it will be now f double dash a. And obviously here also this f double dash a not equal to 0, and it will go so on. So you have to check that each and every time that this f of a is 0 or not, f dash a is 0 or not, f double dash a is 0 or not. But when it will be non-zero, that will be your solution. If first step you will get the non-zero f of a, then your solution will be end there. But if you get f of a is equal to 0, then you have to check f dash a. If f dash a is equal to 0, you have to check f double dash a, and so on. Okay. So now let me take one or two example so that you can understand the rules. Okay. But you have to practice lot of problems. Here I am just discussing some easy problem for understanding the theory also only. Okay. But actually you have to practice more problem. You can join my Telegram channel where I have also given the additional problems along with the handwritten notes. So from there you can practice, and at the end of the course obviously we will discuss about previous year questions also. So don't worry, we will discuss a lot of things. So now let me take a questions on this theory. That is, here given that d square plus 5d plus 6, d square plus 5d plus 6 into e to the power x, y into y is equal to e to the power x. So this is your differential equation written in the symbolic form. So what is your particular integral? So particular integral obviously 1 upon f of d. Here f of d means d square plus 5d plus 6, and then it is e to the power x. Here a is 1, you can see here 1 into x. So what you have to do, you have to put this 1 here, because you have to put, instead of d you have to put a, and a is here 1. So it will be just 1 upon 1 square plus 5 into 1 plus 6 into e to the power x. So 5 plus 6 11, 11 plus 1 12. So it will be e to the power x by 12. So this will be your answer. So this will be your particular integral. Okay. So now let me take another problem where you can find this, that f of a is equal to 0. So let me take another problem where you can find actually your f of a is equal to 0. So you have to go one more step. Okay. So these kinds of problems like d square minus 1 into y, d square minus 1 into y is equal to e to the power x. Okay. So here also a is equal to 1. So your particular integral again 1 upon d square minus 1 into e to the power x. Now you can see here a is equal to 1, and if you put 1 here, then it will be 1 minus 1, that is 0. So what you have to do, you have to take the differentiation of this. So the differentiation of this d square is 2d, and you have to write here x e to the power x. Now if you put d is equal to 1, so what you will get 1 upon 2 x e to the power x. So this is your answer. So this will be your particular integral. Okay. So this is how you can solve this kinds of problem. But if you can find that after doing this differentiation, if you get 0, okay, then you have to take one more step. Suppose if here is d square minus d, suppose d square minus 2d. So if there is a d square minus 2d kinds of situation, then you will get 0. That will be 2d minus 2. If d is equal to 1, then 2 minus 2 equal to 0. Then you have to take one more step. Okay. So you have to check that whether your this denominator is 0 or not. Okay. Now let us move to the next case, that is case 2. Okay. So this is for e to the power x kinds of situation. That is, here in each and every case your r is nothing but e to the power x form. But now if your r is in the form of sine or cosine, so case 2, your r is in the form of suppose sin ax plus b, or if you have cosine of x plus b. So in that case, what will be your particular integral? In that case, your particular integral will be something like this: 1 upon, you have to always need f of d as f of d square. So you have to write your function in terms of this f of d square, and then you have to write this sine or cosine sin x plus b, and you have to put this d square as minus a square. Put d square as minus a square, provided obviously f of minus a square not equal to 0. That means it will be something like this: 1 upon f of minus a square into sine x plus b, this kind of situation. But if f of minus a square is equal to 0, then you have to take the differentiation of this, then you have to put d square is equal to minus a square. So in that case, if your f of minus a square equal to 0, then your particular integral will be like this: 1 upon f dash of minus a square, and 1x will be outside, so it will be x sine x plus b, and so on. So if you get again f dash minus a square is equal to 0, then your next step will be x square f double dash minus a square. Then next step, if f double dash of minus a square will be 0, then you have to write x square f triple dash minus a square. So you have to move until you will get the non-zero value of this denominator. Okay, so you have to check in each and every case. Now again, let me take one example about this case. Okay, for this kinds of situation, that is if the function is sine or cosine. So in that case, one thing you have to keep in mind, you have to write f of d as f of d square, in the form of d square, as a function of d square. Okay, so now let me take one example. Okay, so d2y dx cube, d2y dx cube plus 4 into dy by dx plus 4 into dy by dx is equal to sine 2x. This is okay. Yes, dqy dx cube plus 4 dy by dx is equal to sine 2x. Now let me first write it in symbolic form. So it will be just d cube y, okay, plus 4d y equal to sine 2x. So if you take common y, then it will be d cube plus 4d into y equal to sine 2x. So your particular integral will be what? 1 upon d cube by 4d into sine 2x Okay, now you have to write it in the form of d square. So how you can write it? You have to take common d, so it will be d into d square by d square plus 4 into sine 2x. Now you can see, if you put here d square as minus a square, it will be minus 4. Here a is 2. So if you put d square is equal to minus a square, it will be minus 4. So minus 4 plus 4, it will be 0. So you have to take the differentiation of this. So next step to find particular integral will be 1 upon, this is 3d square plus 4. You have to take the differentiation, and then you have to take one x outside, so it will be x sine 2x. And now you have to put this d square as minus 4. So if you put here this d square as minus 4, so it will be just minus 4. Then it will be minus 12 plus 4, that will be 8. So your answer will be x upon 8 minus x upon 8 minus 12 plus 4, it will be minus x by 8 into sine 2x into sin 2x. So this will be answer. So this is how you can solve this kinds of problem. So in the next class we will discuss the more case for finding the particular integral. Okay.